Hey everyone, in this video what we're going to do is we're going to evaluate the integral of the natural logarithm of x cubed using integration by parts. Now before we get into it, let's just go over the formula for integration by parts. Now, just as u-substitution is the reverse process of the chain rule, integration by parts can be recognised as the reverse process of the product rule. So let's begin with the product rule. We have fg prime is equal to fg prime plus f prime g, where the prime symbols indicate differentiation. Now, if we integrate both sides of this expression, we get fg is equal to the integral of fg prime dx plus the integral of f prime g dx. And if we subtract the integral of f prime g dx from both sides of our expression, we get the formula for integration by parts. That is, we have the integral of f g prime dx is equal to fg minus the integral of f prime g dx. So now that we have our formula, let's solve our integral in the upper left hand corner. Now, what are we going to take to be f? Well, what we're going to do is we're going to take the natural logarithm of x cubed to be equal to f. And we're going to take g prime to be equal to 1. Now, if we differentiate f, we get f prime is equal to 3 times the natural logarithm of x squared divided by x. And if we integrate g prime, we get g is equal to x. Now all we need to do is input this information into our formula above. Doing so, we have the integral of the natural logarithm of x cubed dx is equal to x times the natural logarithm of x cubed minus the integral of 3x times the natural logarithm of x squared divided by x dx. Now we can simplify our expression further. We can cancel the x in the numerator with the x we have in the denominator, and we can bring the 3 outside of the integral sign because 3 is just a constant. In doing that, we get the following expression. But notice we have a second integral, the integral of the natural logarithm of x squared dx. So we're going to have to apply integration by parts for a second time in order to evaluate this expression. Doing so, in the same way as before, we take f to be equal to the natural logarithm of x squared, we take g prime to be equal to 1. In differentiating f, we get f prime is equal to 2 times the natural logarithm of x divided by x. In integrating g prime, we have that g is equal to x. In using our integration by parts formula, we have x multiplied by the natural logarithm of x cubed minus 3 multiplied by x multiplied by the natural logarithm of x squared minus the integral of 2x times the natural logarithm of x divided by x dx. Again, we can simplify by cancelling the x in the numerator with the x in the denominator and bringing the 2 outside of the integral sign, so that we have the following expression. But again, we have an integral that we need to use integration by parts to evaluate. That is, we have the integral of the natural logarithm of x dx. So what we're going to do is we're going to apply integration by parts for a third time and see what we end up with. So, taking f to be the natural logarithm of x and g prime to be equal to 1. Differentiating f, we get f prime is equal to 1 divided by x. And integrating g prime, we have g is equal to x. Using these new values for f and g, we have x times the natural logarithm of x cubed minus 3 multiplied by x times the natural logarithm of x squared minus 2 multiplied by the natural logarithm of x minus the integral of 1 dx. And now we no longer need to use integration by parts because we're just integrating a constant. In doing so, we get minus x plus c, where c is just a constant of integration. And if we multiply everything out, we have x times the natural logarithm of x cubed minus 3x times the natural logarithm of x squared plus 6x times the natural logarithm of x minus 6x plus c, which is the final answer to our problem. But how do we know that our expression is correct? Well, what we can do is we can differentiate our expression using the product rule and the chain rule. Now, I won't go through all of the steps of differentiating our final answer, but I'll list all of the terms once they've been differentiated on the screen. As you can see, a lot of them cancel out, and we're just left with the natural logarithm of x cubed. So this confirms that we have the correct answer. But as a final exercise, why don't you try to find out a formula for the following integral and leave your answer in the comment section below. I'll be making a video on this soon. Anyway, I hope you found that content useful. Thank you very much for watching. I hope you have a great day.